Welcome back, explorers. In this video, I'm going to introduce the use of periodic or repeating functions. Now, in math, there's something called the modulus, and that gives you a remainder when you're doing division. And so right here, we're taking x times 4 modulus 1. Now, if you did like 2 divided by 1, you'd get an answer of 2, but the remainder would be 0. And if you did 2.5 divided by 1, your answer would still be 2, but your remainder would be the half. And then if you did 3 divided by 1, you would have an answer of just 3 with remainder 0 again. So there's kind of this repeating pattern going on. And if we draw this out, here's what we see. And you'll notice that it kind of works its way up from 0 to 1 here, and then cycles back down and kind of works its way back up again. And that's the repeating pattern going on. There's 4 bars. You'll notice we're doing x times 4. And so that's kind of where that's coming from. And it might be a little easier to visualize if we chart what's going on here. So this next one actually does a one-dimensional calculation using the modulus. I guess I don't do times 4 here. I only do times 2 to keep it a little simpler. But it converts the one-dimensional line into a two-dimensional image. And so you can see that here. And you'll notice now what's going on the left. Actually, everything that's below this line would be negative. And so these values in the lower left are actually the negative numbers. And that's because the modulus of a negative number gives you a negative answer. And so I'm actually going to change that in how I use it in my code. And so in my function, I'm going to refer to it as sawtooth instead of modulus, because I'm kind of modifying that behavior. And so I call this repeat sawtooth function in order to do essentially a similar calculation using the modulus, but the result is always positive. And so that looks like this. And then there's another mathematical function that I want to use called sine, and that returns a sine wave. And so we're generating one of those right here. And that looks like this. You can see these more smoothed out bars that are showing up. And I think we'll just do the same thing here. We'll chart this out. So we're going to chart the one-dimensional wave into a kind of a two-dimensional image. And then you can see the wave just goes up and down. But remember, as with last time, that these values that are below this line are actually negative. And that's why when we look at the wave, we see that there's kind of larger black regions than the white regions. There's actually quite a bit that's in the negative space there. And so for the sine function that I use, the repeat sine, I've just kind of normalized those values. It's actually a wave that goes between 0 and 1 instead of -1 and 1. Also, the sine wave mathematically repeats only every multiple of 2 times pi because it's a trigonometry function. I actually just normalized mine to repeat every time between 0 and 1. It has an interval of 1. And that will help make the behavior line up better with a lot of the other math that we're doing going from 0 to 1. And then finally for the intro, I've just used a lot of repeat sine loops, but with a little bit different time multiple for each of them. So essentially the green moves faster than the red, and the blue moves even faster than the green. And so that's how we get the waves that are spinning. And the reason that those beams are kind of shooting out from the center is we're actually using the angle calculation that we talked about in an earlier video as the source value for what goes into the sine function. And that's it for this time. So thanks for watching. Come explore with me again.